So right now you should also be working on that warm-up problems there at the top. This should be starting to get faster for you. We've got, is anybody in here leaving for band? Nobody in this class is leaving for band? Okay. Okay. So what did y'all get for this first one? What are you going to do when you have power to a power?
You add.
Yep. Yvonne was right. What did you say, Yvonne? Multiply. You're going to multiply the powers to the power outside. So y is going to be to what power?
The fourth. 12, huh?
Because 4 times 3 is 12, and then d is
18.
18. Yeah. Now on this next one, we've been looking for the bigger number on the top or the bottom, but when we're talking about the coefficients, the negative is separate. It's just a -1 or a negative. If there's only one negative, it just stays there. So which is bigger of the 40 and the 20?
The 40.
The 40. So what's 40 divided by 20?
22.
And then what am I going to do with the exponent on the s?
Subtract.
Is he going to go on the top or the bottom?
Bottom. Top.
Top, because 6 is bigger. So 6 minus 3 is 3. So then in this challenge problem down here, we've got this whole first piece right here to the power of 2. So you need to do that first. What am I going to do with the coefficient?
Multiply. Oh, no. Multiply?
Divide.
Not multiply, not divide.
Subtract.
Coefficients, remember? So we've got exponents, multiplication, addition.
I said addition.
Okay. But this is our top one. What happens to the coefficients? They do whatever operation we're doing. We're doing exponents.
So then you multiply.
So 14 to the power of 2. It still gets to the power of 2. If you are forgetting that, then remember there's that invisible 1 always there. So this power of 1 right here, and this power of 1 is going to get multiplied by 2. So that's going to be 14 squared. Right? So if you are getting confused, then maybe that's the method that you need to remember, that there's that 1 power there that you're going to multiply by the 2 and get the 14 squared. So 14 squared is what?
It's 14 times 14.
14 times 14, which equals?
Oh my God. This is
196.
196.
Squared.
Nope.
No.
Because we did 14 times 14, which gives us that. What's our A going to have on it?
Oh. Yeah.
A is going to have the power of what?
4.
8.
Oh.
8.
Ooh.
Okay, and B is going to have the power of?
12.
Now I need to do this one. Okay, so these are still going to be multiplied when I get done. So what power does my A have?
42.
And my C?
21.
So now what operation am I going to do to finish?
You're gonna.
Add the exponents, right? That's what I heard.
Yes.
Okay. So 196 doesn't change. So what's my power on my A going to be?
20?
No, because you're gonna add, right?
8 plus 42.
Oh, 50.
And my B
12.
and my C.
21.
So this is my answer right there. So take it one step at a time. Don't try to rush into looking like it's too complicated. When you know how to do it, you know the steps. Okay, so really quick, yesterday on our Get More Math problems, there was some struggle with when you ended up with fractions for exponents. You do not treat rational exponents any different than what you treat regular exponents. If you're being asked to put them in, you don't have these problems. These are just examples from like Get More Math questions that you might have ran into yesterday. So you might want to make a note underneath your yesterday's thing as some additional examples that you could use, or some examples to the side here. So when I have this dot, what's the operation that I'm doing? Multiplying. So what do I do with the coefficients when I'm multiplying?
You're gonna get this like.
It's gonna be bigger numbers.
When I'm multiplying, my coefficients just get multiplied, right? 1 times 4 is 4. What happens to my exponents when I'm multiplying?
You have to change into improper fraction.
Nope, exponents. So what operation? I'm asking you, which operation am I going to do?
Multiply.
If I'm multiplying, if multiplying is my thing, remember my exponents get special treatment, they get knocked down a notch. So I'm going to add my exponents. So 3 halves plus 1 half equals what?
4x.
4 halves. What does 4 halves reduce to?
2.
So the power on my x is just 2.
That's easy.
Okay. So I'm glad to hear you say that, because that's why I'm showing you this, because I think a lot of you are looking at it and go, oh my goodness, that's too complicated, when it's not really doing anything different. It just now has some fractions in it. And you need to get familiar with seeing fractions and doing operations with them. So here we are again multiplying. So what am I going to do with the coefficients? Multiply. So 4 times 5 is 20. And what am I going to do with the exponents on my A?
You're gonna add them.
Add them. So I've got 1 plus 2/3. I want it to be an improper fraction. I don't want to leave it a mixed number.
You have to walk around Texas, right? Walk around Texas.
You can do it that way. You can just put it in your calculator as 1 plus 2/3 and we'll do it for you.
5/3.
5/3. Okay, so A is to the 5/3 power. Okay, and then my B got 3/2 and 1/2. What am I going to do with those? Add them. So 3/2 plus 1/2.
Which is 4/2.
4/2, which is 2. So B is to the power of 2. So that's it for that one.
Okay.
Okay, so what happens when I'm dividing? Okay, so we got roots, dividing, subtraction. So what happens when I'm dividing the terms?
You're gonna divide your exponent.
So divide my coefficients. So 12 divided by 2 is
6.
okay, and what am I going to do with my exponents?
You add them.
You're subtracting them.
I'm subtracting because I'm on my making my numbers smaller
Oh.
ladder, right? So 3/4 minus 1/4 is 2/4, which is 1/2. You're right. So x to the 1/2 power. Okay. Last one. Okay, we've got the power of 3/2 raised to the power of 2. So that's exponents or powers, right? And then multiplication and addition. We're on that side, that ladder. So power to a power, what am I going to do with my exponents? Multiply them. So I'm going to have m to what power? 3/2 times 2
3.
is 3. So
Oh, I see.
that's just m to the 3rd power. Okay, so just because there's fractions in them doesn't change what you're doing. Still doing the same process. Okay. So back to, well, actually, we're still on yesterday's stuff. Really quick, we covered this in this class yesterday, but just in case you didn't catch it yesterday or you didn't quite understand. So a perfect square is the area of a square. Okay, so if I have a square, right, then a square by definition has the same measure on both sides. Right? This is just adding to yesterday's notes because we had some questions come up about it. So a perfect square is 16 because 16 equals 4 times 4. Okay, so this would be a perfect square. 25 is a perfect square because it equals 5 times 5. Okay, or 5 squared. Okay? So on yesterday's problems, okay, here is this list of perfect squares. You guys don't necessarily have this list, but here it is. I'm showing it to you. I did post this picture on Google Classroom if you wanted to look at it. So yesterday we were asked to find the greatest perfect square factor of our number here. So 96. It's not a perfect square. It's not in my list here. So
Was this one from yesterday? Oh.
yeah, these are the problems from yesterday. So if you did them, you need to be checking them. Because we didn't get to check them in class together yesterday, right? So we're working on them right now so you can remember. So 96, okay, we're not going to do 1 and 96 because that's irrelevant. We already know it's not a perfect square. So 96 divides by 2, so that's 2 and 48.
Yes.
Is 48 a perfect square?
No.
No. So what about 3? Does 96 divide by 3?
Yes, 32.
32. Is 32 a perfect square?
No.
No. Okay. So 4, does it divide by 4?
Yes.
Yes.
24? Is 24 a perfect square?
No.
No, 4 is, but we're not sure. It may not be the biggest. So let's see, because this side is our second pick. Okay, so we need to see if that there's something on this other side over here. Okay, that's a bigger number that's going to be our first choice. Okay, so 4 is a perfect square, so I'm not going to mark it out yet, but I'm going to keep going. Does 5 go into 96?
No.
No, it doesn't end in a 5 or a 0, right? So does 6 go into 96?
Yes,
16.
16. That's a perfect square.
That's a perfect square. So ding ding, that's bigger than 4. Okay, if you put them in order like this, okay, so if that you work them out, okay, in an orderly fashion, then the first one that you come to on this big side is going to be your biggest perfect square. You don't need to keep going if you've done them in order. If you've jumped around to try to find your factors, then you may have skipped one. Okay, so we don't need to use this one now because we have our perfect square of 16. So the square root of 16 times the square root of 6. Well, the square root of 16 can be simplified to what?
8.
4.
4. 4 times 4 is 16. So 4 square roots of 6. 6 can't be simplified anymore. Okay? So that would be the answer for that one. If I do my factors of 28, again, I'm not going to use 1. Okay? So 2 times 14
Times 14?
gives you 28, doesn't it?
Yep.
Okay, so is 14 a perfect square?
No.
No. Okay, does 3 go into 28?
No.
No. What about 4?
12 times 12, right?
7.
Oh, 7.
Yeah, 7.
Bro, my brain was
4
not
times
functioning.
7.
4 times 7. Okay, does 5 go into 28?
No.
Does 6 go into 28? No, and then I'm back at 7. So I've got all my factors here. Okay, 4 is a perfect square. So that's my biggest one. Even though it's on my second pick side, it's my only one. So that's the one I'm going to use. So the square root of 4 times the square root of 7. Well, the square root of 4 simplifies. So that's 2 square roots of 7 for my answer for that problem. Then I'm going to do the same thing with 45. Everybody should be checking their work from yesterday if you didn't get this. I mean, I know y'all didn't have it at the end of class, so make sure that you are getting it now because I will be checking notes. So it's not an even number, so it doesn't divide by 2. Does it divide by 3?
No. Yes.
15. Yes, it's 15.
Okay. Are either of those perfect squares?
No.
Does 4 go into 45?
No.
5?
Yes. 9 times.
5 times 9. Okay, so that's on my big side, right? So I don't really need to keep going. If you do, there's no other factors. It doesn't divide by anything else. Okay, so we've got the square root of 9 times the square root of 5. The square root of 9 simplifies to 3, so we have 3 square roots of 5. So that's the first method, and that's the method that we learned yesterday. I also showed you another method, okay, or talked about another method, okay, where that I use the prime factors and the calculator does a lot of the work for me. Okay, so type in your calculator. I want everybody to do these. Okay, so type in your calculator factor, type the word, and put 288. And tell me what you get.
16.9706.
Not the square root of 2. I want you to type in factor.
Oh.
Mine said error. Yeah.
You got to do factor
Store.
and then parentheses,
Oh.
288.
Is 2 with the power of 5 times 3.
2 to the power of 5 times
3 to 2 to the power.
3 to the power of 2. Okay? So we know how to deal with powers that are underneath a radical, right?
Yeah.
So I'm going to take this power of 5 and divide it by 2. What is 5 divided by 2? 2 with a remainder of 1, right? Because we got to think in remainders. So that means I'm going to have 2 squared brought outside, but I'm going to have to leave one of my 2's underneath because I got that remainder that stays underneath. Okay, and then for my 3, right, 2 divided by 2 is 1. So that means I get to have 3 to the 1 power outside here. I can fix that. So I need to simplify these numbers out front here. So 2 squared is what?
4.
4. And 4 times 3 is?
12.
12. So my final answer here is 12 square roots of 3. Or no, square roots of 2, sorry. 4 square roots of 2, because my 2 was left underneath. Right? This one was the one that had one left. So do the same thing for 200. You don't have to type factor in again. If you've already done it once, just arrow up and copy it, and then all you have to change is the number. So arrow up, highlight it, hit enter. Okay, so what is 2 to the power of 3 and what? 5 to the power of 2. So same thing again. I'm going to draw it out this time. So this 2 to the 3rd power is 2 times 2 times 2, right? And if I have a pair of them, then that gets to come out. And I have 1 left over that has to stay underneath. Same thing with my 5s. 5 times 5, I've got a pair of them, so it gets to come out. Okay, leaving the only thing underneath the radical is this square root of 2. So what is 2 times 5? 10. So I've got 10 square roots of 2. And then this last one, what's the factors? Joshua?
3 to the power of 5.
So 3 to the power of 5. Okay, so how many 3's can I take out?
5.
5 divided by 2 is?
2 with the remainder.
2 with a remainder of 1. So I get to take 3 squared out, and I have to leave 1 3 underneath. And 3 squared equals what?
3 squared equals 9.
So it's 9 square roots of 3 for my final answer. So either method is a valid method for you to use. If you like doing it this way, you've got this option. If you like doing it the other way and listing the factors, you have that option. Either one is a valid way to do it. Okay, guys? Back to today's, and you should have picked this up from the back. This was just walking you through the steps the factor tree here, okay, the factor tree is just how to get the factors if that you don't have the calculator to do it for you. Okay, so this walks you through how to get where that you would have 2 times 2 times 2 times 3 times 3. Okay, so notice all these 2's on the end of the branches and the 3's. That's my prime factorization. So 2 cubed times 3 squared. And then that's how you got it simplified here. Okay, so this just walks you through how to find the factors if you don't have the calculator to do it for you. Okay, so back to today's page now that we've covered yesterday. Okay, did y'all happen to get down here and get this chart filled out? Okay, take a few moments and fill it out really quick.
Fill it out.
Yes, fill in these empty spots right here.
What? Oh.
Finish filling it out.
Oh.
So answer question B here. What did you continue to do as the exponent got larger and larger?
You multiply
Multiplied by what?
by the same number.
Multiplied by the same number. In this case, I multiplied by 2 every time, right? So as my exponent got larger, did your values also get larger?
Yes.
Most definitely.
So I have a box here with a question mark in it. What number would go there? Without having to write it all out, what would I put there?
Oh,
It would be 2 times 2.
It would be 32. Okay, because I am, so what pattern did you notice? Right as I go down, I'm multiplying by 2 every time,
No.
right? It's doubling.
Yes.
2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay. So suppose that I wanted to try and go backwards. So if going down, right, as I continue to fill in the chart, as my exponents get larger, I'm multiplying by 2. So suppose I wanted to go backwards, what would I have to do to get 2 to the 0 power?
Divide by 2.
No, it's subtract.
2 divided by 2 is 0. Oh.
And then divide by 2.
But we're not, we got to do the opposite operation. If my pattern is multiplying going down, the opposite would be dividing to go the other direction. You're right. So this would be 2 divided by 2, which would equal what?
1.
1. Does that make sense?
No.
If I took 2 and divided it by 2, would it equal 1?
No.
Put it in your calculator. If I wrote it as a fraction, 2 divided by 2, what happens?
It's 1.
They divide and cancel out, right?
Oh, so
Equaling 1.
Oh.
Okay. So when you cancel something out by division or multiplication, your answer is 1. Right? Because multiplying or dividing something by 1 doesn't change its value. 0 is the addition and subtraction one. So when you are adding and subtracting and canceling things out, then you get 0. Okay?
Why is there so many steps in that?
All the way. Put your phone away. So if that, I wanted to figure out what 2 to the negative 1 power is, what would I have to do?
You would
Divide 1 by 2. So what's 1 divided by 2? 1 half. Right. 1 divided by 2 is 1/2, right? So 2 to the negative 1 is 1/2.
Wait, then it goes by fractions, right?
It would. Why?
I don't know.
because you're dividing.
Because you're dividing, right? And when you divide, things get smaller and smaller and smaller.
Oh, yeah.
Too small.
Okay. So now look at the next page, the top of the next page. So why? So we just kind of talked about this. Why do you think they got a fraction for this negative exponent?
Because the numbers are getting smaller. You're dividing.
And you can change it to a decimal. So.
Dividing, so they're getting smaller. We like to keep the fractions, okay? So leave the fraction there. So now answer this. What is 2 to the third power?
It's 8. It's 8.
It's 8.
It's not 2 times 3.
So we talked about how we had to divide by 2, right, to get this. So if we divide by 2 divided by 2 divided by 2, what does that give you in the calculator?
2 divided by?
Wouldn't that give you 1/2?
No.
Because 2 times 2 is 1.
It's 2.5.
Here it is. All right. So I'm not dividing 2 3 times because remember this 2 original 2 is 2 to the first power. Then that's 2 to the 0. This is only 2 to the negative 1. So to get to the negative third, okay, we would actually have to divide by 2 more times, right? So this is confusing when you think about it this way, right? Because you wouldn't remember how many times you have to divide by something. So look at what 2/3 is. 2 to the power of 3, I mean. 2 to the power of 3 is 8, right?
Yeah.
What's my denominator in my fraction up there?
Which fraction? 8.
The one that we're talking about is 8. Okay?
I said 8.
So the negative exponent means inverse of the positive exponent. So 8 is the same as 8 over 1, right?
Yeah.
And if we talk about the inverse or the reciprocal, then we would have 1/8 because it flips over, and that's the inverse. So your negative exponent means that you're going to take the positive exponent of whatever it is and flip it upside down. Move it to the other side of the fraction bar. So in this next one, why do you think the x disappeared?
Because they canceled out.
Because they canceled out, right? X squared divided by x squared cancels. Okay? And when something divided by itself cancels, it equals 1. Okay? So I do want you to take the time to think about the rules from what we talked about, see if you can come up with one. But I do need to talk about a few more things before you get more math assignment because we're running out of time. We took too long at the beginning of class. Okay. So in these blanks here, positive exponents means we are multiplying the number by itself. Negative exponents mean that we're dividing the number by itself. Anything to the 0 power is 1 because anything divided by itself is 1. So in this one right here, we kind of already touched on this a little bit. This negative exponent just means it's going to get flipped upside down with a positive exponent. I'm going to change the sign. So in this second one right here, why does the 3 end up on top?
Because it's a bigger number.
Oh, it's the only.
It's the only coefficient there, right?
Yeah.
Was it raised to the negative exponent?
No,
No. What's raised to the negative exponent?
the y.
Only the y, right? So only the y gets moved to the bottom because it's the only thing that's affected by the negative exponent.
Why did the negative change to positive?
Because it's the inverse. If it's on top,
Oh,
it's negative, so we've got to do the inverse of it and move it to the bottom. So notice in this one, so you already know 4 divided by 2 is 2. And 4 was bigger, so that's why it's on top. Okay, then we've got x to the 4th and x squared. Well, there's me x squared on top. But then I have z to the negative 5th on top. It's going to get moved to the bottom and become a positive z to the 5th. So if I have something like this, and they're both negatives, okay, and they don't simplify with each other, or they're both negatives, okay, we don't want negative exponents. That's not proper notation. So if you're asked to put it in positive exponents, then that means you're going to move the x to the bottom and make it positive, and move the y to the top and make it positive. Can y'all see my work over there in the corner? So you do have some practice problems on this paper to work through as well, and then you have ones on get more math to do as well. Okay, I won't see you guys Wednesday next week because y'all have the benchmark for the English test, right? Mr. Heflin may be in here on Tuesday next week observing me. So he's coming to one of either second, third, or fourth period. So just be aware of that in case he shows up.
Right.